So the second speaker tonight is an amazing engineer of VMware. Fawad, please kick it off for us to end the night.
Thank you. Guys, thank you for staying here late. We had a great presentation by Toby, so I think you guys know what Kubernetes is. I think you guys already are aware of DCOS as well, so I'll spend less time on Kubernetes and more time on the rest of the things. Before I start, quick show of hands, how many of you are aware of what Istio, Envoy, or Service Mesh is? Awesome, that's perfect. That's like 60% of the crowd. Okay, great. I'm Fawad. I work at VMware. I'm an engineer, and I work in this ecosystem. So in this presentation, we'll talk about what are microservices, what's the role of Kubernetes, briefly, and then what is Service Mesh, why do we need it, and then the architecture of Istio Envoy with Kubernetes, a small demo in the end with some use cases. So you remember this, the monolithic applications, the complicated days where you had everything, jammed up into one big module, big application, different modules, dependencies, issues. The releases were slow. The customers were afraid of, upgrading because you had to time your stuff. Things had to be solved in a way that it would become easy for you. What was the solution? A trick question. Anybody? Microservices. So everything was, kind of split into smaller modules that you could, work on yourself, version yourself, and don't have to worry about kind of create an abstraction, communicate over the network. No more big applications. Customers are much more comfortable now at this point. Even you can deploy your application at your own pace. The velocity has completely changed. You get all of these benefits by the use of microservices. And we all know the flexibility, easier packaging, easier deployment. You can deploy multiple versions. But does that solve all of the problems that which were there? Yes, but it does create some new problems. Those new problems are as part of this change of migrating towards these microservices that I think all of us have embraced already. What are the complications? So we used to be able to manage these monolithic applications very easily, because one big deployment, things are just working. At this point, you're managing hundred or thousands of endpoints and these containers, packages. They were long-running processes at this point. You have stateless, short-lived containers that have a short life cycle, may have a short life cycle. When that happens, their IP addresses may change. How do you discover them? It's not easy. Somebody has to solve it for you. You have to secure thousands of applications now, which used to be maybe 10, 20. At this point, life is becoming difficult. You have to know where they are. You have to be able to secure them. You also have to define the access control between all of these endpoints which are running. And it's not going to be easy. So networking is becoming complicated there. There's latency increase. Previously, you would have everything in one box, so you never had to worry about access control. It was like a no-op. No more anymore. Things are going over a network. And also the monitoring aspect of one big application, you would hire some company or you would create something which would run as part of this big app, monitor it, know whatever is going on inside it, how it's doing. At this point, you're looking at so many of those. The factor by it has increased is 100x, and which creates a lot of mess when you're looking at networking aspect as well. So how do you solve these complications? And this is where you have Kubernetes and Service Mesh teamed up, where Kubernetes takes care of most of it. It's able to deploy your application, auto scale, self-heal, service discovery, load balancing, all of those things are there. We all know what benefits of Kubernetes are. What Service Mesh offers over here is the monitoring capabilities in a quite simple way, and we'll go over how it does that. You don't really have to worry about changing the application code or writing something very specific to your application. Controlling your traffic, advanced routing, rich policy-based routing. I want to have different version of my application. I want to route some part of it here, some part of it there. How do you do that? We'll see. About security, you want to be able to secure all of these endpoints. How do you do that? Service Mesh has a very nice way of doing that. Then the last piece is where I think it's really gaining a lot of traction is the rich policy-driven operations. You could do fault injection, you could do circuit breaking, access control, advanced routing, rate limiting. Sounds very much like SDN. Yes, it has some overlap, actually a lot of overlap, and you'll see more as you go along. So what is a service mesh? Let's talk about a service. What are the requirements of a service, that microservice that we run right now? We have a microservice which normally has or requires an API server, if you want to secure it, maybe with TLS, a client that you want to have retries on because if something fails, that's essential, running production. You want to do ACLs, you want to do load balancing, circuit breaking, authentication, and monitoring. Very important. This was, if you break down into all of these components into small pieces, you would have to have separate teams working on these components individually for your application, which means every single company would have a version of its own for their own application, or some platform you expect to magically come and provide all of these things. Turns out Service Mesh takes care of lots of these areas. So what it does is that it takes everything and moves it into a container except for your application code, which means you have your application code separately and everything else we've talked about in a separate container, which works as a proxy. And since every packet goes through it, it's able to take these things and send it to the respective, maybe monitoring system or some ACL to check, if it's policy allowed or not, etc. How does it work? So let's say we have a Kubernetes pod here. Before you run an application container inside, we all familiar with it, makes sense. You want to add TLS? Yes. You make it part of the app container, or maybe you have multiple containers running over there inside one pod. You want to add matrix, so you add something over there for that as well. You want to add retries, so yes, maybe your application is designed to take care or cater for these things. What happens now when you introduce Service Mesh? You have another assistant container or package or a process which has everything running inside it, and it works as a proxy. Everything goes through the sidecar container. The terminology is sidecar. And this sidecar is responsible for taking care of everything other than your application. And this is where the power of Service Mesh comes in. What are the features and what are the areas of problems that Service Mesh is solving right now? It's authentication, access control, load balancing, retries, telemetry, fault injection, routing, advanced routing, fine-grained routing, very powerful. Lots of CI/CD use cases and other things. When you talk about your application deployment, you can really use this to make it happen. It's super easy to do it. That's the best part. And the language which is being used over here for defining these policies is also super rich. Before we move on to the details of how it works, let's talk about the landscape. As I mentioned, sounds very much like SDN. So there's a control plane, there's a data plane. There are a few technologies which have been there around trying to solve this in a very similar model. So the first one that I've heard about was SmartStack. It's been there for quite some time. Airbnb was the one who came up with it. It was designed for VM workloads. Then Nelson came out. Verizon open source engineering team came up with that project. It's also trying to do very similar Service Mesh kind of model, but it has these data plane, it's integrated with Envoy. Then Istio came up mid this year, 2017, which is solving the Service Mesh problem. On the data plane side, Envoy is a project, is a very smart L4, L7 layer proxy, was developed by developers at Lyft. Then Linkerd is another one which was introduced by a company called Buoyant. It's still out there. It's integrated with Istio. Then HA Proxy and Nginx, you guys are aware of those. We'll talk about Istio and Envoy specifically in this presentation. So Istio came up open source. Teams at Google and IBM were the ones who started it. There was partnership with Lyft developers to integrate it with Envoy. And now Istio is integrated with many more things. Linkerd announced that they have an integration with Istio a couple of months ago. There are other things which are also coming up over there. Istio was first integrated with Kubernetes. They have a very strong a nice integration over there. The 0.2 release just came out a couple of days ago, where they have announced more integrations with other areas. So let's talk about Istio Service Mesh. How does it look like? So a very simple diagram here. You have two Kubernetes services, Service A and Service B. You have your own set of pods running inside each service. Whatever traffic that has to go to and from your service will be sent to your Envoy or sidecar first. This Envoy is a smart proxy. It's capable of taking these packets, doing something with them based on the filters that you define over there, and send them to the Istio control plane, which is responsible for sending this data either to an external system for, let's say, monitoring, or asking an external system or some system for, let's say, policy, or using its own database where you have programmed rules to enforce that policy onto the traffic that you do over there on the use cases. Like if you want to do secure communication between Service A and Service B, Istio would have, let's say, a policy in one of its component where you can say they can't talk to each other. So your packet will go from Service A to Envoy, and this one, it will go to the, it will route to the other Envoy. When it does, the Envoy on the Service B will check, is it going to allow packets from Service A, yes or no, from the Istio control plane? If yes, of course, they can talk. And similarly, when, if I want to do metrics, it will send data to control plane, which can expose, etc. Any questions so far? Yes. Yeah. I will make them available. Yes, I will. Layer 3. Yes. Layer 3. Yes. Any other questions?
So it needs to be in one cluster, or Kubernetes cluster, or multiple Kubernetes cluster?
The previous release, they had one cluster. In the new release, they can do multiple clusters as well, as far as I know. If not, they definitely have it in the next release. Yeah. Okay. So I'll move on. There are other content. If I'll be here. Questions. So Istio has a few components here. The data plane is the Envoy, which was the first integration with Istio. Also, that's not a requirement. I mean, you can have your own. You could, let's say, tomorrow you decide to write your own data plane proxy. You can do it. Integrate with Istio. It's very simple. There are APIs that you have to write, etc. So anyway, it came out from developers at Lyft. It's a very smart edge or service layer L4, L7 proxy. Pilot is a component as part of Istio control plane. What it does is that it programs all of these proxies at runtime. You program a rule, it will know where to go, and once you program over there, it will set it up. Mixer is a very key component. That's where all the brain of policy happens. It has two interfaces. One is on the proxy side, which is your data plane side. The other one is on the external systems. For example, you have a monitoring system, so you would have an adapter which will interface with that system. Or let's say you have a policy system which is running outside. You would have an adapter for that. This works as an intermediate layer between these two worlds and allows you to enforce that policy. Istio auth is responsible for mutual TLS and secure naming. So that's where the security communication between different envoys happens using the auth. All right, I'll go to architecture. Slowly, we're going towards some of the diagrams here. As you see over here, let's start with this portion where we have the service. So that's your Kubernetes pod. Your pod is running. I need to be close to the mic. Can I use that? Yeah. So your pod is running over here. As I mentioned before, your pod is running, or a service is running a set of pods. It has a container. Let's say your container is a service container. As part of that, when you launch it with Istio, what it does is that it injects the sidecar as a container inside it. And it uses some init part as well. So what it does is that it launches this container inside this pod. It also programs some IPTable rules, which says all the traffic for the service has to go through Envoy. And on the way back from Envoy, it will go through this service on the local host. So all the communication for the service happens on local host. You launch the service as part of Kubernetes. So the service gets registered with Kubernetes, which means Kubernetes knows about it. Pilot talks to Kubernetes to learn or discover these services, because Pilot has to make this information available to all of these data proxies, because they also need to know where to route traffic to, or DNS, service discovery, naming, etc. has to happen. So Envoy has to know. What Envoy does is that it listens on the Pilot API about these changes. That's one of the things that it does. The other thing is that it discovers information about routing, circuit breaking, traffic splitting. So those rules that you define are part of Pilot, and those rules, I think I can use this. Yeah, those rules become part of Pilot through a command line utility or an API, and then those rules are discovered by Envoy that it can force. Mixer can also be programmed using this command line utility called Istio CTL, where you can define, okay, this policy, my YAML file, this guy can talk to this guy, and this guy cannot talk to this guy. Mixer has this configuration that you program or operator programs. Envoy checks that information while the packets go. Now, somebody may have a question: is it holding down to the packet while making the decision? Yes, it holds to the packet, holds down to the packet, and checks with Mixer, can the packet go? Yes or no? To improve this, Istio community has added the mechanism of caching. So there's caching over there, which improves it a lot. The other responsibility of Mixer is that it ingests data from all of these data plane proxies for monitoring, for example, or tracing. For example, Envoy has been sending some traffic for a service, for example, this service over here, some set of attributes that you can define inside the Envoy configuration. Based on those attributes, it will send data to Mixer. Mixer will know, okay, this belongs to Prometheus driver, or maybe Zipkin, or maybe some XYZ monitoring system. It will send to the respective system over there. To improve the performance and scalability, the areas of this thing, you can actually turn on batch reporting as well. So you don't, send every single packet. You can hold on to it, send in batches. So those kind of things and enhancements have been there. So the work which has been done so far in the first two releases has been incredible. A small community, but very efficient, and it's amazing progress that they've made. I'll take a pause here. Any questions? We'll move on to the use cases and the demo. Yes?
How much time does it take to make a decision to communicate with Mixer?
It's really, really fast. I have not characterized it. The time will really depend on how big your system is. So this kind of characterization is something Istio community plans to do in the next release. And based on the characterization of this performance and scaling, they'll see where to work on, spend time on, improve that area. Yeah.
This diagram shows the data path, control path.
Yes.
Dashes control path.
No. Well, it's mixed. That's not done this way. Anything that's Envoy and service does in between is your data path. Everything else that you see over here is control. So the communication which is happening from CTL to Mixer and Pilot is control. Envoy asking Mixer about what's the policy that I'm supposed to enforce is also control. Data only goes through Envoy to Envoy through service and etc. or outside the system or from inside the system. Any other questions?
So the information that you mentioned Istio modifies the of the pod while it's running the pod. Controls such that all the time.
There are IP table rules inside the pod which says all the traffic has to go through Envoy proxy, and then Envoy proxy makes the decision if there's a monitoring data it has to send, if it has to block the request from somebody trying to request access to the service that it's working with. So does that answer your question?
Yeah. So among other services that's running in the same pod, eventually when, let's say, delayed Istio control service wakes up, it would be after that it would update that.
Can you comment?
So you have a bunch of containers that run as part of that pod, one pod, anyway, right? And then the Istio as one more container. Is eventually when that thing runs, one update.
You have to. So I understand the question. So let's say you have.
I was asking
You have some applications running. I think your question is, you have some applications running already, and you want to just insert this service on top of those. How does it work? So you install Istio, and you say, okay, inject these sidecars into these applications which are running. Or when you launch a new application as part of the spec, you can just say, run it with the Istio, service mesh capabilities. It will do that. In the previous release, there was a magic command which was used to Istio inject, Istio cube inject command used to inject these sidecars into these pods. Starting the 0.2 release for yesterday, that has changed. So it's part of Kubernetes system. So it's much improved. Yes. Last question, and then we'll move on.
Yeah,
yes.
I mean, I'm wondering about service migration, moving service from one to the other. What are the challenges you face? The policies that you're talking about, they're present everywhere,
But
on a need basis?
so you have as part of Kubernetes, you define a service, right? This sidecar is running inside your service. So it's not going to make any difference. You migrate your service, it's with it. Service has the same identity. As long as that remains the same, it's not going to matter, which means if it has the same identity, Istio is going to know about it. So everything is like closely integrated, so no impact from that perspective. Okay. I'll move to some of the use cases. There are some basic use cases here. Visibility that I talked about, I was saying it. This is how it looks like. You have your Kubernetes service, which is running something, whatever it's going to be. Your Envoy will report this data. Mixer is one of the control plane components. Mixer has some set of adapters that you can easily write on your own that interface your system. So let's say over here, you have a Prometheus adapter for Grafana. It will get those metrics, send to Grafana, which can see. Similarly, Zipkin, if you want to do some tracing data over there, you can do that. What you see here is the powerful thing is you don't have to modify your application code at all. You don't have to write any of these specialized monitoring policy service on your own separately. This is like a one solution, works for all. It's quite amazing from that perspective, very powerful. Another use case is traffic steering. For example, you define a policy rule which says any traffic, any L7, you're looking at L7 over here, let's say, any traffic coming from HTTP header with the user agent iPhone, send to version 2 of this application. There's one service running 4 pods. One is on version 2, other on version 1. Kubernetes supports it. How does it work? Istio makes it super easy for you. Just find one rule. It will do it for you automatically. It's going to know what service is, what version is where. Look at the packet. Based on that, we'll route it accordingly. So it's like a tip of the iceberg, the capabilities that can be exposed using the rich policy language that it has. I mean, IBM had their own policy language, which was taken into the Istio project. It's quite powerful. Another use case is access control. Service A says, I want to talk to service B. Before that happens, there's a precondition check, which they will reach out to Mixer. Mixer will have, let's say, a built-in deny check adapter. Simple, whitelist, blacklist. Will say, OK, yes, you can. Sure, it will go through. If not, your request will be denied. You can also write your own adapter to interface with your own authentication system or access control system. Those capabilities are there. Somebody asked me a question that is it checking for access control on every single packet? The answer is no. It checks only if there are attribute filters which are added to the Envoy instance through the Istio deployment. It will only check those. Otherwise, it's not going to do that. Otherwise, it's a big overhead. So let me just repeat. Envoy has a configuration file, Envoy.json, which comes from top down. User doesn't have to modify it. If you define those filters over there, OK, these are the filters I'm looking for, only then it will go and check for conditioning. Otherwise, it will not. All right, with that, we'll go over a small demo. I'll use the standard Istio book info app. So what this app has is 4 components. There's a product page that you landing page, a product page. Over there, it displays you reviews about something. There are 3 versions of reviews. It has details page, and the reviews talk to the ratings page to get the rating information. The piece that we have to pay attention to is that reviews has 3 versions, version 1, 2, and 3. Version 1 does not talk to ratings, so it does not show you or display any ratings. Version 2 talks to ratings, but it shows you black stars. Version 3 also talks to ratings. It shows you not black stars. I'm colorblind, so maybe brown, orange. So this is a system which is running without Istio. When you run with Istio, this is what it looks like. It's running on Kubernetes. So you see these envoys have been injected into these services. You have the control plane running, which are also a couple of containers in the system and the Kubernetes. Very simple, small deployment. Now you want to apply access control policy. How do you do that? So you define a small YAML file where you say, OK, I want to have my source label, which is a label in Kubernetes app, matches reviews, and it has a version 3. If this is the case, block traffic to ratings. I apply this policy on ratings. And when that happens, all the requests coming from version 3 to the ratings will be denied. Let's say you want to change that. You say all the traffic from all the reviews applications should be blocked. So you change your rule. You say, OK, match source label, app reviews. It's like a wildcard. It's going to block all the traffic, which means you will not be able to see these reviews. And if you remove this rule, of course, the traffic will start going through. This is what I'm going to show you in the demo right now. I have a setup running. Let's see if it's still up. So what I have is an Istio namespace, system namespace, which is running the Istio components. So what you see over here is the authentication, ingress, egress, mixer, and pilot. These are the control plane. Let's look at the default namespace of Kubernetes. I am running this book info application. You see all the same parts that we were talking about are the services, 3 review versions, ratings, product page, and details. Let's go and try to access this. OK, let me export the URL. Let's see if this is accessible. All right, it's already open. So, all right. So what you see over here is this is a review area, details, reviews, talk to the review app. It should be able to show us the reviews. So I keep on refreshing. There's a load balancing going on. We see the stars are changing, which means it's talking to it's going through a different version of reviews on each of these requests. Now, as we go back to slides quickly, just to remember, version 3 has these orange stars. So what we'll do is I will go back and write a policy rule over here, which says, OK, block everything coming from reviews and version 3 going to the ratings app. And once we do that, the policy is enforced at this point. I should not be able to see any of those orange stars or version 3 information. At this point, I'm refreshing. It should be black or none, which means version 1 or version 2. If I want to enforce the other part of the policy, which is, forget about the version, block everything coming from all the reviews, that can be done as well. Let's do that. Before that, I'll have to remove the policy, which is already there. So I'll do that and recreate. Done. At this point, I should not be able to see any stars. And there you go. That completes the demo. And this shows you how easy, super easy it is to enforce policy using Istio. No code changes in the application code. Everything is going to the envoy. in the sidecars through the Istio control plane. Super simple, APIs and interfaces, but very rich in terms of the feature set and capabilities that it offers you. With that, thank you very much. Please join the Istio and Envoy communities. And questions? Yes.
This policy behavior is enabled by IP table.
No. It's I can go back quickly to show you. So we added this policy, this spec that we had, YAML spec. We added it. This was added into Mixer. This went to one of the adapters here, which is the deny check adapter. This adapter is enabled at this point. It has this policy enforced inside Mixer. When the packet goes from Envoy, from the ratings review app to the ratings app, which is here, reviews app to the ratings app, ratings has this policy enforced. So ratings will check, am I going to allow packets coming from this guy? And it will say no, and it will check with Mixer for that, and hence it will drop the packet, or it will say no, request not granted. No IP tables for policy, none of that. The policy is actually enforced inside the Envoy, that sidecar that's running.
What happens to the service outside of the
It's service mesh is currently, it's designed for application, like these are microservices. So if something is outside running on bare metal, something else, it's not designed for that yet. I know that Istio has in the roadmap to integrate VMs as well. I'm not aware of bare metal yet. Yes, VMs for sure. 0.4 release VMs integration is coming. Yeah. You.
let's say that I have that very large environment that I'm not how do I know what does that apply across the environment? Just like kind of the example. What you based on those changes back out when it's actually shown.
I think this calls for some automation on top of this. You definitely don't want to do these through CLI or manually. So where if you're aware of the system, your Kubernetes system, you know what services are running. Based on that, you could just automate through the API what's going on, and there's a log of everything that you do. Based on that, you could make your decisions, etc. It's a good question. I'm not aware of if there is a notification which says on the control plane things have been completely deployed from a rule deployment point of view, but that's something it's definitely in the logs, but exposing it should not be super hard. Feedback for the community. Yeah, thanks.
So is this being used in production currently in VMware, and at what scale?
Okay, VMware. Okay, so VMware is just coming up to speed. I mean, we have been looking at it until recently, and we are very interested in this one. And we will be contributing as in the Istio community and Envoy because we see a lot of value that it creates, and there is open source component that we will be working on this aspect. Yeah, not using VMware on the production side of things. Istio, I'm not aware if anybody's using production. It's quite new. It came out in May 2017. So we just had the second release a couple of days ago. There's a still long way to go, but very promising. Yeah. Any other questions? Yes.
What's the mechanism by which you program the inside?
What's the mechanism?
Are you
Yeah.
CNI plugin or?
No. Okay, good. So what's the mechanism of programming these IP table rules inside these service containers? The way it works is that, are you aware of init containers inside? Yes. So it uses init container. Whenever you launch this pod, it has an init container, which it has the responsibility only to write this IP table rule, which means your pod cannot be launched or upgraded if this init container with IP table rule script does not get executed. So it does that, and only then your application creation or updation happens.
It's an operation snippet namespace, or you have a separate namespace?
It's the one namespace inside your container, which is shared across all of these containers.
Last live question. Anyone?
Any other questions? Yes.
All right.
What part of the system can crash if your application can still route traffic?
Come again, please.
Like Kubernetes, like the whole control plane can crash, things still works. Crash, still traffic flow between different networks.
If your mixer is down, you will not be able to enforce policies. But we don't expect mixer to go down. Mixer, part of the architectural intent is that mixer should be HA and should remain 99.999% available, which means if any control bit goes down, things are not going to work. So, but the availability or the architecture intent will ensure that things will stay up and running. Yeah.
Are there multiple instances of mixer running?
Not yet. There will be. Yes. That's the architecture. That's why I'm saying it's an architecture intent. Current implementation is one.
All right. If anybody has any more questions, I'm sure Fawad will answer them for you.
Yeah, I'm here.
And one more quick thanks to our speakers tonight. Give them a big round of applause. Yes. Our next meetup is on November 16th at Palo Alto Networks. We've got Code Fresh. I've seen their talk literally 5 times, and I love it every time. And then we have Project